Well, this question, pray to Almighty that this should not become in 1 mark question, because it has come many times in 1 mark question, because it will be difficult to explain it. Well, we can directly write its answer if no justification is asked, but if justification is asked, then it will be a bit problematic, bit lengthier. So a biconvex lens made of a transparent material of refractive index 1.5. So refractive index of glass, we can say, is 1.25. Immersed in water of refractive index 1.33. So another situation is there, water 1.33. Remember, lens is not made up of water, lens is placed in water. Will the lens behave as a converging or diverging lens? Okay, so in order to understand that, we have to find refractive index of glass with respect to water. Remember the formula, 1 upon f equal to eta minus 1, 1 upon r1 minus 1 upon r2. In this formula, this eta is not any eta, it is the eta of glass, refractive index of glass with respect to air, if that lens is placed in air, or it is refractive index of glass with respect to that medium in which it is placed. Right now it is placed in water, so we will replace it with GW. We have to calculate it, G by GW. So it is 1.25 upon 1.33. That is something around 0.9. See, it is less than 1. When we will put this value here, 0.9 minus 1, 1 upon r1 minus 1 upon r2, we will get a negative value. That's all, we are not going to calculate it. It's a negative value. So negative focal length means its nature is diverging. So diverging. We can also explain it in a different manner, like refractive index. This is an alternate method. Refractive index of glass is less than refractive index of medium. So nature of lens will be reversed. Nature of lens in that medium will be reversed than that in air. So earlier it was converging in air, so it will be diverging in that medium which is denser than the glass. Same type of question is here. A biconvex lens made up of transparent material, blah blah blah, refractive index 1.5, eta g is 1.5, and it is placed in water, eta w 1.33. Will the lens behave as a converging or diverging lens? So first way to answer is this, second way to answer is this. So we'll follow this way. Eta GW is eta G by eta W. 1.5 upon 1.33, it is something around 1.2. 1.11 some 1.5 something, so 1.2 roundabout. So 1 by f equal to eta gw minus 1 upon r1 minus 1 upon r2. This is 1.2 minus 1 upon r1 minus 1 upon r2, which is a positive quantity. So its nature will be converging. Okay, in a different manner, eta of glass is greater than eta of medium. So nature of lens in that medium will be same as that in air, because air is also rarer than glass. That is why it will retain its nature. So I think these lines are helpful for both kind of lenses, whether they are converging or diverging earlier in air. So if a lens is placed in a medium which has greater refractive index than its medium, then its nature will be changed. If it is diverging in air, so it will become converging in that denser medium, and vice versa. But if medium is rarer than the medium of glass, that glass medium of the lens, then its nature will retain same. It will remain same as that in air. Okay, so here, okay, so I want to make a slight change in this question because, well, mirror for this 2021 session, mirror topics are removed. So I'm all right, no problem. I'm replacing it with the lens. So when an object is placed between f and 2f of uh, what uh, what else I can do? A part concave lens, B part convex lens. So now A part, and it has two more parts. B part, it has two more parts. Okay, so the first part, concave lens. We know concave lens always produce a virtual image. Oh, I want to just change my words, because no other condition is given. So, well, I want to change my words. Uh, this thing, whatever I'm writing here, it is true when that lens is placed in a rarer medium, when medium is rarer. Otherwise, situation will be changed as we discussed earlier. So, keeping in mind that medium is rarer than the medium of that lens. Refractive index of lens is greater than the medium. So then it is true only. Okay, so then that concave lens always produce virtual image. And second, diminished or magnified, so diminished. So be careful about this. Once again, in this question, I have no problem writing these things, but you should remember this thing. They can ask that glass has a refractive index 1.5 and it is placed in a medium of refractive index 1.75, and then they can give this situation. So now it is placed in denser medium, so it will not retain that behavior, it will change its behavior. So be careful about it. Anyway, for this question, things are simpler, life is easy. Okay, so convex lens, if object is between f and 2f, we know uh, its image is real, and it is magnified between f and 2f, so it image formed beyond 2f on other side, so it is magnified. All right, so okay, an object is kept in front of concave lens. Comment on nature of image. So once again, this is an incomplete question, but not so incomplete. If nothing is given, then it means under normal condition, under ordinary condition, means it is placed in air. So uh, general answer will be image will be virtual, erect, and smaller size in front of lens. But remember, I'm giving you a second thought. If it is placed in a denser medium, then entire situation will be changed. Well, there are some other questions also, but I will cover them later on. Right now, I'm going with the flow. Does critical angle depend? And same thing you can do in the exam also. The question which maintains your flow, go with them, flow with them. Does critical angle depend on the color of light? Explain. So, yes, answer is yes. Big yes. Why? Because we know that sine IC is equal to 1 upon eta, and also eta is inversely proportional to lambda medium. So we can say uh, so IC depends upon lambda, and that's true uh, if lambda increased, so IC also increases. Both are in inverse proportion, so both are in we can't say, yeah, sine IC is directly proportional to lambda, then we can say, because sine IC is in direct proportion with lambda. What else? A biconvex lens has focal length 2 by 3 times that of radius of curvature. Once again, 1 mark question, but lots and lots of computation is required. So 1 by f is equal to eta. We have to find eta here. Yeah, no, it's okay. Eta minus 1 and 1 upon r1 minus 1 upon r2. Convex lens f is 2 by 3 radius of curvature. Radius of curvature, let us suppose, I'll write that r. So it is 2r by 3. r1 is r, r2 is minus r. So we'll put the values here. So it will be 2r by 3 is equal to eta minus 1 need to be calculated, 1 by r minus minus, it will be plus, so 2 by r eta minus 1. Oh my god, what is this happening? Oh, Big mistake, big mistake. So student, we the teacher can also do the mistake. It is 1 upon f actually. It is 1 upon f. So correct it. And now it is 3 by 2r is equal to 2 by r eta minus 1. R will get cancelled. So it will turn out to be eta minus 1 is equal to 3 by 4. And therefore eta is 1 plus 3 by 4, that is 1 right 3 by 4, so it is 7 by 4. Okay, define power of lens. The converging or diverging ability of a lens is called power of lens, but go mathematical for mathematical definition. The reciprocal of focal length is called power of lens. P equal to 1 upon f. And its unit unit is diopter. Unit of power of lens is diopter, and 1 diopter equal to 1 upon 1 meter. 1 diopter is the power of lens whose focal length is 1 meter. An equiconvex lens, equi means convex on both sides, equi, bi, double, all of these are the name for simply convex lens, curved on both sides. Refracting index mu1, focal length f, radius of curvature r, is immersed in a liquid of refractive index mu2. For mu1 greater than mu2, mu2 get mu1 less than mu2. Draw ray diagram when 2. Okay. So they have asked to draw ray diagram, and it's a very easy question. So in first case, okay, mu1 is the refractive index of convex lens, and here is mu2. Mu1 is greater than mu2. It's an ordinary case, means it is placed in a rarer medium, so it will act as it used to act, simply converging action, nothing else. Now here, I hope you people have predicted it, what I want to say now. Oh my god, they have written it mu, so I need to follow their symbols. This is how flexible we have to be. So mu2 is greater, so its nature will change. That's all. Okay, so now it's a very interesting question taken from the NCERT book. Actually, most of the questions have been taken from that. But in NCERT book, they have given some horrible values like 30 degree, 35 degrees, 47 degrees, and all that. And knowing that calculator and log tables and sine tables are not allowed in the exam, but still they give. And but remember, student, if you practice those type of question, remember they will either give the values of required sine or cosine, whatever come in the exam, or they will give good values, known values, as I have taken. So you can blame me that teacher is going through easy path, but yeah, of course, this is how board exams are designed. The board exam paper is designed. So now first case, second case, and third case, we have to predict this angle. Predict actually calculate this angle. So they have used the word predict, so actually we can calculate it. Here, refractive index of water with respect to air is sine I by sine R. Sine I is sine 60 by sine 45. We will solve this. Root 3 by 2 by 1 by root 2, that is root 3 by 2. Second one, eta glass with respect to air. So this is sine 60 by sine 30. So this is sine 60 is, I'm directly doing this. So root 3 by 2 upon 1 by 2, so it is root 3 only. Now here, refractive index of glass with respect to air is equal to sine I by sine R. So here we have refractive index of glass with respect to air, of course, upon refractive index of water with respect to air, of course. And this is sine I is sine 45 upon sine R. So sine R is equal to eta WA upon eta GA sine 45 degree. Eta WA is root 3 by 2, entire root, and upon eta GA, somewhere here, GA, oh my god, GW, oh here I did a mess, GA it is, GA, it is root 3, and then we have sine 45, 1 by root 2. So something known to us, oh, double root I have applied, so these things happen with you people also. Okay, this will get cancelled, 1 by root 2, 1 by root 2 will be multiplied, rest of it I am doing here. Don't do this thing in your exam, you can turn the page, I can't. So it is 1 by 2, it means R is 30 degree. Alright, so here it is, you are given following 3 lenses, okay, 1 2 3, which 2 lenses will you use as an eyepiece and an objective to construct an astronomical telescope? So what I am going to do, I will find the focal length for each. F1 for first lens, that will be 1 upon P1, that is 1 upon 3, that is 0.33 meter. F2 1 upon P2, that is 1 upon 6, and that is 0.167 meter. And F3 is 1 upon P3, that is 1 upon 10, that is 0.1 meter. So for an astronomical telescope, the basic requirement for astro telescope objective should have larger aperture, longer focal length, and eye lens, smaller aperture, shorter focal length. So now longest focal length is this one. So lens 1 can be used, lens 1 can be used to make objective lens. And for eyepiece, we have two same aperture, but the third lens has minimum focal length. So L3 will qualify the criteria for that objective eyepiece. So okay, so I have this one, eyepiece L3. All right, objective lens of two telescope हैं आपके, have same aperture, but their, why this is required, but their focal lengths of objective in the ratio 1:2 equal focal length of eyepiece. Compare magnifying power. So we know power is FO by FE. So for two lenses M1 by M2, we can have FO1 by FE upon FO2 by FE. FE is same, so we can say FO1 by FO2, and their focal length is given in the ratio 1:2. So answer is 1:2. Simple question, 1 mark question. Earlier question was also of 1 mark. So this is how in a question we lose time, in another question we can gain that time. Why must both objective lens and eyepiece of compound microscope have shorter wave focal length? So for compound microscope, M, their magnifying power, M is given by V0 by U0 1 plus D by FE for when final image formed at D, and when it is formed at infinity, it is V0 by U0 D upon FE. So it is pretty sure that FE is in the denominator, it must be shorter. But why objective should be of shorter focal length? So we can say that UO is approximately equal to FO. So MD, what I want to mention, magnifying power of compound microscope when final image formed at D. This much information this MD carries. So it will be VO upon FO 1 plus D upon FE and for m at infinity, VO upon FO. Not to be used in this manner, but actually UO is very close to FO. That is why we are using it in this way. It's an approximation. So clear from, we can say it is clear from the equation that for greater m, FO and FE should be smaller. So that's all in this video. Now some long questions I will cover in next video.